Okay, guys, so yesterday we looked at balancing chemical equations just using the chemical symbols. Today we're going to recall our knowledge of nomenclature and do the same thing that we did previously, balancing chemical equations, but just using word equations instead of the symbols. So for chemical equations with words, what we need to do is we need to take each of the words and put them into our equation form, or write our formulas out. So iron 3 chloride, let's recall back that that 3 stands for the fact that iron is going to be a +3 charge, and chloride has a -1 charge. So +3 -1, least common multiple, would be 3. So we need 1 iron, and we'd need 3 chlorines. So 1 times 3 will give us 3. 3 times 1 will give us 3. Plus sodium hydroxide. Sodium is Na. It's got a +1 charge. Hydroxide is OH -1. Least common multiple is 1. So NaOH yields iron 3 hydroxide. We have the +3, the -1. So we would need 3 hydroxides to the 1 iron. And sodium chloride. Sodium's +1, chloride's -1, 1-to-1 ratio. NaCl. Now that we have our equation, we are able to then go out and balance it. Reactants, products, iron, chloride, sodium, and our polyatomic ion travels from one side of the equation to the next as a group, so we can leave it as OH. We have 1 iron, 3 chlorines, 1 Na, 1 OH on the left side. We have 1 iron, 3 OHs, 1 Na, 1 Cl on the right side, or our product side. So we're going to just pick an element and work on balancing that element. So we're going to go with chlorine first. We have 3 chlorines on the left. We're going to need to put a coefficient for 3 on the right hand side. So that's going to give me 3 NAs, and it's going to give me 3 chlorines. So chlorine's now balanced. On the left side now, because I had 3 NAs, on the right side I need to put a 3 in front of the NaOH. This gives me 3 sodiums. It also gives me 3 OHs. Now if I look at my numbers, I now have a balanced equation with the proper number of atoms of each type equal on the product side and the reactant side on each side of the equation. Now one of the things when we're writing out formula equations from words, we have to remember the 7 diatomic elements. So whenever we see these alone, we have to remember that they're diatomic in nature, and we have to write them as so. An example of this would be in the following equation. We have aluminum bromide. So aluminum has a +3 charge based on its position in the periodic table. Bromide, or bromine, has a -1 charge. Least common multiple of Al and Br would be 3. So we need 1 aluminum and 3 bromines. Plus chlorine. So chlorine is one of those 7 diatomics. So whenever we see chlorine, we need to write it as a diatomic, Cl2. Yields aluminum chloride. So we know chloride is a -1 charge. Aluminum's a +3. It reacts just like bromine, so it's going to be AlCl3 plus bromine. And bromine's another one of our diatomics, so we know that it's going to be Br2. We then make our list, reactants, products. We have aluminum, chlorine, and bromine. we have 1 aluminum on each side, we have 3 bromines on the reactant side, and we have 2 on the product side. We have 2 chlorines on the reactant side and 3 on the product side. So, for each of the halogens, we see we have 3 and 2, and the least common multiple of 3 and 2 is going to be 6. So we're going to try to get this 2 to 6 by putting a 3 there. So that gives us 6 chlorines on the reactant side, which means we now need 6 chlorines on the product side. So we put a coefficient of 2 in front of aluminum chloride, and this gives us 6 chlorines. But this also gives us 2 aluminums. To fix the aluminums and balance aluminums out, we need to put a 2 there in front of aluminum bromide on the reactant side. This gives me 2 aluminums, but it gives me 6 bromines. And 2 times what gives me 6? A coefficient of 3 in front of the bromine. And if we look, our atoms on each side of the reaction are balanced, and we now have a proper chemical equation. Continue working on this, or give this sample a try, and see you in class tomorrow.